Hi everybody, let's start our course of microprocessor interfaces, which was stopped because of this lockdown. I hope everyone is doing good, and now we are at a position where we can discuss at assembly level programming of 8085. So starting with the lecture, a series of lectures will be coming for the same assembly language programming of 8085. So this is the first lecture we will be discussing. The topics which we will discuss today is the introductory part of the assembly language programming of 8085. There is a programming model. So, what are the hardware devices which supports programming of 8085? We'll see all those concepts today. So, today lecture outcomes is, so once you complete this lecture, you will be able to understand the different registers. Some registers are programmable in nature, some are non-programmable in nature. When you say programmable register means you can use it to manipulate some data. You can use it while you were writing some series of instructions to complete a task. We can utilize those registers of 8085. So we'll see all those. Next, you will be able to differentiate between assembly and machine language. So please bear with the noises which will be coming because of in the morning time there are so many noises coming throughout your environment. Okay, let's start now. Okay, so microprocessor is an executing device which executes your instructions. Whatever instructions a user provides, microprocessor executes it one by one. So where does these instructions get stored? Obviously, these instructions are at some locations of the memory. Okay, so one by one, microprocessor has to start with a location, then jump to the another location until it finishes all of your instructions, and then finally it produces its result. And results get stored either in the accumulator. This is one of the 8-bit registers of your 8085 microprocessor, or you can redirect the result to some other output port too, or any other peripheral device which is acting as an output device for your microprocessor. So what language? I'm sorry, I don't know why my computer is talking about the color now. Okay, so instructions should, what language your microprocessor understand? Obviously, since it is a machine, it understands only zeros and ones. Means only binary patterns can be understood by the microprocessor. So all those binary patterns which is understood by your microprocessor, you can tell them as a machine language. No. Why machine language? A language is nothing. A language is way of communicating between person, between community. So since it is a machine, it understands only in terms of zeros and ones. It's called a machine language because only 0 and 1s can be interpreted only by machine, not by humans. If I say 0, 1 to you, it doesn't mean anything. But a machine can interpret it as a register or some kind of operation too. So for example, you can see, so it's a 8-bit instruction. As we know, our microprocessor is a one word is of 8-bit in case of 8085 microprocessor. So each instructions can be of either 8-bit or 16-bit or maybe sometimes 24 bits too. But each 8-bit can be interpreted by your microprocessor independently. Like here we can see 0 1 0 0 and 4 1s. So it's a valid machine language instruction of 8085. What does it do? Whenever you provide this binary pattern to your microprocessor, it copies the contents of a particular register into another register. Means source is also a register, destination is also a register. So copying the content of one register into another. This is the pattern which is specifying what microprocessor has to do. Next, coming to the, you can see we have to add two different numbers which are residing in the two different registers of the microprocessor. Like register A is having data 2, so H is for hexadecimal, and 4 is another data which is residing in B, and H is again for the hexadecimal representation of the number. But again, 2 and 4 in hexadecimal is equivalent to 2 and 4 in decimal 2. So what you have to do is, first you have to copy the 2 into register A. So first pattern you can see 00 followed by 5 ones and followed by 10 is copying data into register A, and then second pattern is nothing but the data itself. So again, third instruction here you can say this one is for copying this 4 into register B, and this is nothing but the data 4, and finally you have to add and store the result into the register. A is nothing but an accumulator. Both of these registers are of 8 bits, and your work has completed. Once microprocessor sees this pattern, it means it will add A and B's content, and it will store the summed results into the register A. Okay, so what is the meaning of assembly language? So every microprocessor like 6800 given by Motorola, 8086 developed by Intel. So every microprocessor has its own assembly language. When you say its own assembly language, means a language is built upon some set of characters. Like in case of assembly language, actually our smallest building block is nothing but the instructions. When you put instructions sequentially in a group, so you will be doing some particular task. So particular task has to be completed by using a combination of instructions, but not with a single instruction. That's why assembly, since 8085 has its own instruction set, so assembly language will be limited only for 8085. But other microprocessors like 8086 is having more 2 raised to 16 different instructions, and its instruction set is quite large with respect to 8085. So here we will be discussing about assembly language of 8085 only. So how it is different from machine language? Because in machine language we have seen we have to write patterns in binary, but here we can write in English. So, and it is human understandable as well. Like you can see, okay, all those instructions which you write in English is called mnemonics. So assembly language, first part is mnemonics. You will write add, move, sub. Like example, you can see when you write MOV, means you are indicating that a data transfer has to be done. Moving, MOV is nothing but the short form of moving. So either you're trying to move a data from particular location to another location. When you say add, when you write add in English, ADD, means you are trying to add two values, because addition needs at least two. It's a binary operation, it needs two operands to work on. Then SUB is for subtraction, then you are trying to subtract between two values, and so on. So the same addition program we will see using the assembly language here, which we have seen earlier in form of machine language, where you have written all those binary patterns. Here what we have to do is, first we have to move a data byte into a particular register. So we are moving into A, the data is 2 in hexadecimal. So you are copying a data into register A. So A will be holding now 2. Again register B will be holding 4, because you are using MBIB, 4H. Move immediately the data byte into register B. Finally you are providing add B, means A equal to A plus B. See here, by default every arithmetic instruction accumulator has to be participating. So here there is nothing mentioned like register A, only add B is written. But your microprocessor, when you write the same instruction in binary pattern, your microprocessor understands that I have to contact with the accumulator's content, then B's content, then I have to sum it and store the result into accumulator itself. So So accumulator's data will get changed. First, earlier it was be having only data 2, but now it will be holding data 6 after the addition happens. So as I said, assembly language is specific to a given process because of the instruction set of different processor is different. And like we discussed earlier, no, 8085 is different from Motorola 6800 microprocessor or 8086 microprocessor developed by Intel itself. 8085 microprocessor is also developed by the Intel Corporation. Okay, so you know your microprocessor is going to understand only machine language, and microprocessor cannot understand a program written in assembly language. Then, but human can write only assembly language. No, then assembly language has to be converted using some logic. Before going to the processor, it has to be converted into the machine language. So we need an assembler to do that. So you write a program using assembly language, then it will be inputted in the assembler program, and then your assembler will change your assembly instructions into machine language code, and then microprocessor gets it and execute your instruction, and whatever result you want, it will print for you. Okay, coming to the programming model of it. What do you mean by programming model? When we say programming model of any particular processor, means we are trying to see what are the parts of your microprocessor which is participating when you write a set of instruction or any instruction. When you write, what are the parts which will be helping the microprocessor to complete the task given by the user in form of instruction. So here we will be discussing the different registers, different control and timing units, and data bus, address bus, as well as control bus too. So here in this diagram you can see accumulator, arithmetic, logical unit, then certain flags are there, instruction decoder is there. Instruction decoder has to, your instruction is sitting in the memory, it has to come to the instruction decoder, means your microprocessor will decode the instruction. What does you want from your instruction? So microprocessor will understand only instruction decoder decodes the instruction for it. Then register array, what are the registers available with microprocessor, and memory pointer registers. Because everything is sitting inside the memory, then you have to go to the memory to fetch the instruction. Actually microprocessor has to do it. So using some address buses, control buses, and every task has to be done. Okay, so we have in our 8085 6 general purpose registers, which is individually of 8 bits, but when we combine it in a pair, we can use at 16 bit, like B, C, D, E, H, L are 6 different general purpose registers, but B and C combinedly can act as a 16 bit register too, same way D and D, and same way H and L. So accumulator is an 8 bit register which has to participate in each and every arithmetic instruction you are going to use. Flag register is also 8 bit registers. Out of this 8 bit, 3 bits are unknown and 5 bits is used for the different flags. Each flag is nothing but a flip flop, and because each flip flop is capable of holding 1 bit, so its status gets changed according to the arithmetic or logical operations happened in the previous cycle. Then stack pointer is of 16 bit, program counter is for 16 bit. Program counter is nothing but it is indicating the next instruction sitting in the memory, because next instruction has to be executed. So program counter will be indicating always the next instruction going to be executed after the current execution happens. A stack pointer is nothing but pointing the stack memory of your microprocessor. So we'll discuss in detail. So 8 lines are bidirectionals, which act as data and act as a lower address bits of the microprocessor. Then 16 lines are for unidirectional line, because it is address lines, and out of these 16 lines, 8 lower bits is combined with this, then you have to use address latch enable pin to differentiate between how demultiplexing has been done. It's another task concept which we have discussed earlier in the classroom itself. Okay, so overview of 8085 programming model. So 6 general purpose registers are there, accumulator register is there, flag register is there, program counter register is there, stack pointer register is there. I might be not having much accuracy in making this video because this is my first experience. Please bear with me. As the time passes, I will improve myself and more efficient videos without having more gestures and noises you will see. So please bear with me until I complete this session. Okay, so we have 6 general purpose registers named as B, C, D, E and HL. So each of these registers independently of 8-bit. As I said, we can use it combinedly for completing the 16-bit operations too in form of B, C, D, E and HL. So what is accumulator? So identified by name A as it is written here. So when you write some instruction and mentioning a register named A, it has to, microprocessor has to interpret that you are talking about the accumulator. So it's a part of arithmetic logical unit of your microprocessor. That's the reason every arithmetic and logical operation may require accumulator. That the data on which you are working, if it is a binary, then it is for sure that accumulator will have one operand, another operand can be in the memory, can be in the other register like C, D or H or L. So it has to participate in every arithmetic and logical operation when it is in the nature of binary operation. Result of an operation is stored in accumulator always. Then coming to the flag register, it's also 8-bit register, but only 5 flags are available in case of 8085 microprocessor. So we'll see, and actually the flags, no, when you make an instruction either arithmetic or logical, so after each and every operation, flags has to be set or reset based on the operation done previously. Like when you are subtracting two numbers and a negative result is getting produced, like 4 is getting subtracted from 2, then minus 2 will be the result. In that case, sign flag should be 1 because your result is in as a negative number. Then 0 flag, whenever result of your instruction is 0, then accumulator's content will be 0 and 0 flag will be set. Same way carry flag, whenever a carry bit generated by the operation, then carry flag will be set, otherwise it will be reset. Parity means when your operation produces a result and results get stored in the accumulator and it has even number of ones, then a parity bit will be set, otherwise parity flag will be reset always. Then auxiliary carry flag is also a concept. We will be discussing everything in the detail and might be discussed in the classroom too. So these, as I said, 5 flip-flops in flag register because each flip-flop will be capable of handling only 1 bit at a time. Okay, so arithmetic and logical operation can set or reset these flags. Condition of flags can be tested through software instructions. Like, see, whenever we are doing experiments in the lab, there is no way we can. We can check. Checking the flag registers will be difficult. So we can use since you are home now, you can download GNU simulator of 8085 and try to execute some instruction, and meanwhile you will be able to check different ports result. If you are redirecting some output at a particular port, then you will be able to see what is the port's content at particular completion of particular instruction. Then again here we can say the result of each and every flag separately. So I advise you all to use GNU simulator for 8085 assembly language programming. So if the request comes, then I will decide how to use 8085 simulator. Few batches I am taking the lab of 8085, so they might be knowing that how 8085 simulator works. Those who don't know can put me a request on the Moodle, so I will make a video of how to use ZNU 8085 simulator, so that you can be benefited after using it. So 80, and what is the meaning of this setting or resetting these flags? So you can make some decisions. So like you have to loop, then you have to make a decision. For example, you have set a counter and you want some of your instruction to get executed until and unless counter becomes 0. So every time your counter will get decremented by 1, and you will be checking the flag 0 flags content. When it gets 0, you don't repeat all those instructions. That's how you make decisions using the flags. Then coming to program counter, as I said, it's a 16-bit. As I said, it's 16-bit memory pointer register. It is locating. Okay, so you know the address bus width of 8085 is of 16-bit. So to keep an address or process an address, the program counter has to be of 16-bit. That's why program counter is of 16-bit. So you have you might be having 2 raised to 16 different memory location at a time, but this is not the case because the memory is not cheap. So sometimes we don't install all the memory which is your processor is capable of addressing. So but address bus width is always 16-bit. That's why program counter is of 16-bit. So you are executing a series of instructions. So after one instruction another, and each instruction will be having a different memory location. So there have to be some indicator which says that at this memory location the next instruction resides. So this work has to be done by your program counter. Program counter always indicating the next instruction which is going to be executed in the next cycle of your process. No. So how does it do it? When next instruction byte is to be fetched by 8085, whenever 8085 is busy executing the current instruction, your program counter changes to the next memory location on which next instruction is residing. So, okay. Then finally we are at a stack pointer register. See, all the memory available. A stack memory is not a different memory actually. So you write a program in such a way that you have subroutine call, like you are looping. So you will be calling same set of instruction again and again. So it becomes a subroutine. Then you have to address it accordingly. No. So a subroutine, for subroutine call, a stack pointer register comes into the picture. It keeps the star. It's a stack pointer. Stack pointer, one pointer is enough for a stack, because a stack works only one location at a time. So a stack pointer will be at the top, then you will be getting down in reverse order of your call, subroutine call, because stack is the first in last out approach. So last call of your subroutine will be executed first, and a stack pointer is the one which gets incremented after each call of your subroutine. So whenever you are writing a subroutine, so your stack pointer starts working and indicating the stack. So a part of memory behaves like a stack, whatever available memory you have in your with your 8085 processor. Okay, so whenever you call a subroutine, your stack is created and a stack pointer register is holding the top of the stack always. That's all about programming model of 8085 microprocessor. So in case of references, I always suggest you to go through the book Ramesh S. Kamkar and read it You will see so many examples will be there in the book. Otherwise, NPTEL course is available by Professor Santanu Chattopadhyay. So you can audit that course also. Meanwhile, if you have any doubt, you can start discussion after I upload this lecture on the Moodle. So I will upload this video on the YouTube. The link has to be provided through the Moodle. Please go through the video, and if you have any doubt, I always try to answer your queries whenever you put. You can use WhatsApp, Gmail, or you better stick with the Moodle itself. So you might have installed Moodle application in your mobile. It's beautiful lightweight application. I suggest you to install that. Okay, see you in the next lecture. Thank you.